Guys, I've finally pulled off something I've been wanting to do for years in Onshape. I'm Evan Reese, the Onsherpa, and I help teams get all the juice out of Onshape, but that's by day. And by night, I'm doing weird stuff like this. So check out what we've got going on with this custom feature. It can do stuff like this. It can make things like that. It can also do some things like this. This is not a mesh. This is real Onshape geometry. We can section through it. You can see that all this texture is included in our section. There's no mesh going on here. Here's another example, kind of a basket weave texture. You can get these fading patterns. And again, there's just a single surface. These have no edges, but it's still kind of a macro texture. Like you wouldn't want to just use a mold tech texture or something to produce this in an injection molded tool. This is a texture that probably needs to be included in the model. You can also use this feature to do lithophanes, and those are objects where it's a relief kind of a carving, and when you shine a light through the translucent object, the thinner areas are brighter, the darker areas, the thicker areas are darker, and it actually makes the image really pop. So you could do a portrait that doesn't look like much until the sunlight comes down at a certain time of day in your window or something like that. And then extending that idea, I thought it would be interesting to make a lampshade that's 3D printable. And again, this kind of doesn't look like much right now, but once light shines through this, it'll look like a panoramic mountain landscape. So this feature does all of this displacement. And the key was finding a way to get Onshape to read pixel values from images. And by default, you can import images and use them for things like the decal or sketch images. But FeatureScript doesn't have access to the contents of the image. It can just point at it. But a file type that it does have access to is a CSV file, like you would get from a spreadsheet. So the real key to making this possible was me and ChatGPT working together to create this really ugly app that does just that conversion. You can give it a JPEG or a PNG, and it'll spit out a CSV with the row and column sizes that you tell it to. So that's the key. And then the displacement map feature uses that as an input. So let me just show you the input of the feature first and how that's all set up. And then I'll show you how to convert an image to a CSV. Then we'll talk a little bit about how you might go about creating some of these images from scratch or getting them from somewhere else. And then wrap it all up maybe with some cautionary tales, because as with other features I've written, this one's really bending the rules, and if you end up bogging down your model, it's your fault. So I want to give you at least a little bit of common sense on how to use this feature, how not to use this feature, and all of that. So let's take a look at the interface here. This image, I just chose a letter P because it's easy to tell if it's flipped or rotated. And so that's all that I've got going on here. So I'm going to drag this all the way to the right so we see the final result. But I had an input body. It was this kind of saddle shape thing just as a tester. And so I clicked the face of that cube. Not a cube anymore, but it was. That's the input face here, surface to displace. And then this is the CSV, and I have all these other ones that I've imported. And then once we're in here, we can flip and rotate the image. So that will flip it top to bottom like a mirror. And then this can clock it around in the 4 main directions. And as a convenience to myself, especially when I have an image that isn't as clear as this from just looking at it, which side is up and down, I've got this show image coordinates down at the bottom. And so it will show you, the red is like the right direction. The green should be like the up of your image. And then this blue should be pointing out of the face. So if I flip this, you'll see that this coordinate system is flipped as well. So actually, like if we were to hide this part, you can see that the letter looks correct from this direction. So I'm going to flip it again. When you're done with that, I recommend turning it off. It does take just a tiny bit of compute, and every little bit helps. So even when the feature is completed like this, if you had that on, it's still taking a little bit of math just to do that. Okay, moving on down here, I have black value and white value. And you've seen maybe things like this elsewhere, but with our depth map, what we're really doing is we're looking at a grayscale image, and anything that's black, we're gonna take that image, and I have 64 by 64 for this default, or it's whatever the rows and columns of your CSV are, which could correspond to pixel values at that point in your image. So if the value is black, we're going to give it whatever value you put in here. And if it's white, we're going to give it whatever value you put in there. And if it's in between, we'll give it an in-between value. So that's really all we're doing. And then for each point, we're just putting a point on the input surface and then moving that point up and down based on whatever color it is a grayscale value it's associated with. And then once we've got all those points put where they're going to go, then those become the control point grid for a B-spline surface. And so the actual, I've got my black value at 5, but we're not guaranteed that the height of the P is exactly 5, in the same way that we're not guaranteed that a Bezier curve actually touches its control points. So we're basically dimensioning, from here to here, up and down, not from here to here. So keep that in mind. Also, because this is a B-spline surface, we have the option to change the degree. And the degree, essentially, you can think of it as smoothness. Lower numbers are going to be less smooth. More crisp could be the good side. And then the downside is that you get this kind of pixel effect going on because it's not so smooth. So 2 ways around this. One is crank up the pixel count, and that's going to make the feature much slower. So I advise against that if you can get away with it. And then the other one is to increase the degree and watch this thing begin to smooth out as we go. And 15 is the max, so let's see what that looks like. Very smooth. And in fact, let's see how smooth it really is. I'm gonna use Shift-C to turn on my curvature combs for this surface. These are very smooth. They transition smoothly between one another, and likewise in the opposite direction, really smooth curves. Whereas if we are at degree 2, these are very choppy. I'll kind of step up a couple of times so you can see what we're working with. See how it begins to really smooth out. 5 is a pretty good balance, I find. Yeah, see, for this one, I would actually want a little more than 5, or I'd want to increase the point count because that's a little more wobbly than I would like. 9, I think, was where it was. Okay, so going on down here, we have the option to replace the face automatically. It's just the same as using the replace face command here. And it does have this flip alignment. Sometimes you need to, sometimes you don't, and I haven't yet been able to figure out how to tell exactly which it's going to be. So that's there if you need it. If it fails the first time, try flipping it. If it fails that time, turn this off and figure it out with other features downstream. I'm going to turn it on. Okay, and then the last thing that I have is this use caching check. If I uncheck that, it's going to do everything that I described every time the feature runs, which is every time your feature studio or your part studio regenerates. So those steps are read the CSV, put all these points all over the surface, 50 by 50 in this case, move them in and out based on the black values, then create our surface through that. So what caching does is it takes all the points that exist and it doesn't recalculate them. So it just saves them inside the feature. And that's well over half of the weight of the feature. So a lot of the regeneration time goes just to putting those points on the surface and scooting them in and out. So caching will keep that. The downside is caching will no longer respect upstream changes. So if I were to change the shape of this face to something different, it still had all of those old points, So if I don't replace face, that might actually update. Yeah, it updated the cache when I changed something in the feature, but let me undo that with I'll just change it back to something else. Okay, so now we're not replacing the face, and you can see that this is still based on the old one, even though this face has changed. Now I do have this checkbox that says warn when out of date, and it's on by default. I say just leave it on unless it's causing you some real problems. But what it'll do is it'll look at the input face and compare that to what's cached, and it'll let you know if they don't match anymore. So at least the feature will turn red if it needs to be updated, and you can just click update cache to make that happen. It also updates if you just change something in the feature. So if it's up here and I change this, then suddenly it's like, oh yeah, we're live again. So that's how the caching works, and I recommend really using it for pretty much anything. And it's not that bad. Let's see here. Input face has been modified. Update. So that went away. It's not that bad of a feature. 98 milliseconds is pretty fast. But that's partly because of how few points I used, and partly because I'm using caching here. Okay, so that's the gist of how to use the feature itself. And the link to this converter, you can just visit this URL, but I'll also put a link to it in the description. Okay, so let's actually go and edit something in a graphic software and make our own map. And I want to show you really, in case it's not clear yet, exactly what's happening with the values we're working with. So I use Affinity Designer, but you can use anything you like. I'm going to use a medium square here, and just to make it something really obvious, I'm going to just put a square here and make it go from black to white in a gradient. That's not white. There we go, all the way to white. And I'm going to save that as a JPEG. Great. Yeah, I already had one because I was testing this out. Back in Google Chrome and at our little image converter app, I'm going to grab gradient. I'm also going to sort by date modified. So it's at the top. All right, gradient. And then I'm just going to hit convert to CSV and download. Great. All right, so now I need to import that. Import, there it is. Displacement map, select a CSV, search for gradient, here we go. We'll displace that surface. And right now the white is set to 1 and the black is set to 0. I want to actually flip it. So I want the white not to move and I want the black to actually be something very pronounced. Look at that. We've made a ramp because if you can picture it, the gradient we made goes from white and then it ramps in a linear way all the way to black. And that's what produces this shape. Now, if you already know graphic software somewhat well, then you'll probably have access to something that has a curves adjustment. And we can use that to change the shape of the gradient. So if I pull this upward like that, it's making it so that the white is more pronounced and then ramps upward and then it changes quickly. So it's like well, I'll just show you. So we got this, let's export that and we'll call that one gradient curved. Back here, we're going to convert that. Download it. And here, I'm just going to right click the original one and update and give it the new one. And you can see how the values now are not transitioning in a linear way, so neither does the ramp. So you can use those kinds of effects to your advantage. Now, realistically, I wouldn't model a ramp using this feature because it's gonna produce a sloppy surface. It's good for textures, but look at all this wibbly wobbly. You just model this. But it's a good demo of what's going on. let's actually make a slightly more interesting pattern just so you can see what we're working with here. So one thing I might do, and this is not really going to be like a tutorial on Affinity or any of these tools, but I just made a triangle that is representing a quarter of that square. And then I'm going to put a gradient here. And you remember that our gradient's just going to create a linear ramp. I want to flip it, actually. Just do that. So the tip is white. And then you can do this in whatever way, whatever tool you have. But in my case, that's going to look like this, where I can pattern that around. I'm going to group it and begin to array these. All right, so now we've got pyramids, and I'm going to export that. Call it pyramids. Now in this case, it actually would not be the worst idea to count how many we have and choose a pixel value that is divisible by that number. So we have 1, 2, 3, 4, 5, 6 wide, and I probably want to make sure that I have 5 points here. So it would be 6 times 5 or something like that is probably good. It's 30, and we could do 60. So let's just do 60. Cool. And you can link and unlink the aspect ratios here. Oh, I got rid of the file. Let's see. There we go. Download. Back over here, we're going to import pyramids as a CSV. And then inside of our displacement map, I'm going to swap this. There we go. And I had flipped this around. Let's go ahead and replace that face. Flip it, see if that works. Yeah, cool. So using that 2D image, we're creating this 3D texture, and it doesn't have to be on a flat surface either. This could wrap around a cylinder or do anything that we want. And we can actually edit this image. So I'm gonna go in here and do a couple of things. I'm gonna make it fade around the edges by just creating a big black outline like this, and then I'm gonna blur it. So now the ones at the edges are gonna fade out. I might do a really big blur. 500 is too much. Let's do 200. And I'm actually gonna make this bigger too. All right, so now it's gonna fade out at the edges. And if I wanted to, I could also just, just to show you what it might look like, put in something gray, like middle gray, so that it won't be the total height. And I can blur that too if I want it to blend with the stuff around it more. We'll just see. I'm not 100% sure what that'll look like, but let's try it. And I'm just going to update this one. Because the feature is already looking at that, it will just go ahead and pull it. Yeah, so there we go. We've got the same pyramids pattern, but it fades out at the edges and then has this sort of like middle height flat area in the middle. So you can do a lot with layering things and having these fading gradients and all of that. And that's how I accomplish things like this, where it's, I have a hexagonal pattern that's one thing, and then I come in with gradients and kind of paint out the fade. And you can get some really subtle stuff going on. That's also really similar to how I did this. I did that as a 2D graphic that's just big and crisp and like black and white lines. And then I blurred it, and then I came in and painted out the areas or used gradients to make sure that it fades in the way that I want, and then got that put onto this surface. Now that's if you want to make your own displacement maps, which is really handy for making really tidy textures, but there's other ways to do it. I'm not going to be able to cover them all here. One great one is to use polygon.com. And there's other places as well that you can find bump maps, displacement maps, and things like that. So you can find some textures like that here. I'm gonna grab this stone wall one. I'm looking at their free ones. You can get you can pay if you want to get a lot. So I'm gonna download this, and it has all of these layers inside. So the one we're looking for is the displacement layer, or bump. One of these two is probably gonna be pretty good. We'll just try them. So here's displacement, and here's our bump map textures. We can't convert TIFF files, so we're going to use JPEGs or PNGs. That's fine, either one. And let's see, back over here in Chrome, I'm going to refresh the page to just clear any of the aspect ratios out. Go to where this is. Let's try the bump first. And because this is a detailed texture, I unfortunately need a detailed number of points. So let's try 250 and see how that goes. This is still going to slow the feature down a lot. It's kind of exponential, really. So be minimal with the number of points you choose. Now I'm going to go ahead and convert the other one to the displacement, and we can compare them. So displacement as well, convert and download, and then I'll bring both of those into here, and we'll do them on this model, just so we can see. Downloads. All right, get prepared to wait, and if it goes too long, I'll fast forward it. Let's find those displacement textures. Let's do the bump first. 3 millimeters is probably gonna be a lot. Maybe not, I guess, if it's real like stony. Okay, it looks like maybe the values that I have are reversed. Like I think the bricks should be sticking out, not the grout. So let's do that instead. And it also seems like none of the values go to the extremes. So what I might actually prefer to do is edit this. Yeah, let's do that. I'm going to take you over to Affinity Photo, where I'm going to edit the values to push it to the extremes of black and white. Okay, here we are in Affinity Photo. And yeah, we can see some of the issue is like the grout is lighter than the bricks themselves. So we might want to modify this a little bit. I can invert it to fix that problem. So now the bricks are sticking out. And then I also am going to add a levels layer. And we can see that most of the values are clustered right in here around middle gray. So I can move the black level into just the very tip of that. I don't want to begin to lose information. I can move it a little bit more. So, you know, if I move it in here, it's beginning to clip. And like a lot of the things that were different values are now just all white. But if I put it way out here, kind of at the end of this long tail, this looks like a normal distribution, kind of a bell curve. So if I put it way out here, I'm not losing too much information, and we are now going to use the full possible range of values. So I think that's going to be a little better. I'm gonna tighten it even more, just to try it. Okay, so now I'm going to save this again, and we're going to convert that, and I think that's going to work a lot better for us. Save it to our downloads folder. Back here, let's convert it. Okay, and that was the bump. I'm going to update this. And it's going to take time, and I'm going to skip ahead in the video because it's going to take too long. Actually, that was surprisingly quick. So one sip of coffee and we're back. Let's see what the regen time was. It feels like it was faster than that, but that's interesting. Okay, so here's what we're looking at. And remember that if you have a detailed image, you're not going to be seeing the full detail unless you push Shift-R to view in high quality mode. It's going to actually go get more triangles for our render mesh tessellation, especially when you see artifacts like that. This is obviously like some triangles going on here like that. Because to render anything, you have to actually triangulate it. So there we go. That's a truer representation of the texture that we're looking at. Let's try the other one. I'm curious myself. And I sort of suspect that this one will benefit from some post-processing as well, which I have not done. So we'll see what we end up with. I want to try it as is to see what we get. I'm going to turn off high quality mode just for a second. Yeah, this one actually does look a bit better and without any edits. I'm going to turn high quality back on, but it does seem like the displacement map from Polygon is going to work better than bump, which I guess is, if we had just read the name and believed it, then we would know. Now, right now, this one's about 9 seconds on regeneration time, and just let that be a cautionary tale. Ideally, your entire part studio is going to take less than 9 seconds. So this is really heavy. I would not do this just because you have something that is made of stone or whatever. I wouldn't do this to add things that are just aesthetic to your model just to make the model look good. I would only do this if you need to produce the texture for manufacturing, really. So that could be 3D printing, but it could also be molding or CNC or something like that. And to add on to that, you can work with this in a suppressed state. This is not the kind of feature that's hopefully going to have a ton of things in the future dependent on it. This is the kind of feature that can stand alone. So if you build your model in such a way that nothing else breaks when this is off, strongly recommend that. This one's regenerating extremely fast now. And then right before I release or go to production, then I can unsuppress this and deal with the regeneration time. But let's go in here and see what we gain by using caching. I'm going to turn that on and just complete the feature. All right, with caching on, we're down to a 1.7 seconds. So earlier I said that doing all the points was about 50%. I was wrong. It's a lot more than that. So using the caching is a big help if you want to keep this feature active at all while you're working on your model. But realistically, if you can get away with suppressing it while you're not using it, even better. All right, that's it. I would love to hear how this hits you. Is this something you're actually going to use? Is it going to unlock anything for you? Do you have questions? Is there something I didn't cover? Almost certainly. So let me know in the comments, and like and subscribe and all that. I've got links to this feature and to the image converter in the description of the video. Thanks for watching. See you in the next one.